I'll first talk about the schedule of the day. The first session is scheduled to commence at 9:30 a.m., followed by a 15 minutes break. After the second session, a 1 hour lunch break will be observed from 1:15 p.m. The third and concluding session will begin at 2:30 p.m., and the symposium will formally conclude with a valedictory ceremony at 4 p.m. It is a pleasure to introduce Dr. Aswani Kumar Chaudhary, Professor at the School of Computer Science Engineering and Information System, Weller Institute of Technology. With over 24 years of academic and research experience, his contributions span machine learning, information security, encrypted network traffic analysis, and quantum computing, with particular emphasis on post-quantum cryptography. More than 200 research publications, over 5,400 citations, and an Edge Index of 36 reflects the impact of his work. As principal investigator, major research projects worth 10 million USD have been successfully executed along with the guidance of 8 PhD scholars and international research interns. Since 2020, consistent recognition among the top 2% scientists in India in AIML have been accorded through a study conducted by Stanford University researchers. Author of the book Encrypted Network Traffic Analysis, published by Springer, he currently serves as adjunct professor at Vilnius College of Design, Lithuania. A senior member of IEEE and ACM, vice chair of the IEEE Education on data mining and ACM distinguished speaker. His contribution extends beyond research into academic leadership and global engagement. On behalf of everyone present, to Dr. Aswani today and express our gratitude for joining us virtually today. The stage is yours, sir.
Thank you. Am I audible? Hello? Am I audible? Can you please confirm if I am audible? Okay. Okay. So, and also whether my screen is visible. Because I'm not able to see the screen.
See your screen.
Okay.
And also, sir, we'll be able to interact to you via chat box only because there's some mic issue going on. But yeah, we'll be able to interact with you via chat.
Okay. Fine. Thank you. Okay. So let me start the session. Okay. So now today my presentation would be on data security. At the outset, I would like to appreciate and thank the organizers of the Data Nexus 2026 National Symposium organized by the Dayananda Sagar College of Engineering. And especially I would like to thank Dr. Harish for inviting me and giving me an opportunity to talk to you and present my lecture to all of you today. So my lecture for the next few minutes would be focusing on these aspects. I will be talking about what is data security and its importance. Divide the data security into three aspects. One is on securing the data when it is in rest, meaning when the data is in format, how to protect that data from unauthorized users. Next, we also discuss about securing the data when it is in the transit or when it is in the motion. Then we will discuss about securing the data while it is being computed or while it is being analyzed in computing. That is the third dimension of it. Then I will also touch upon the current order of the day. That means the quantum safe security, the principles behind the quantum safe security, and what are the algorithms that are there in the quantum safe security. So these are the points that I would like to discuss in the next few minutes of my session. All of us know that we are living in a digital world, where we are interacting with people in the rest of the world. We are storing our data. In fact, we are creating lots and lots of data. We are storing that data. We are analyzing that data. When you look at all these things, we are actually are in need of protecting this data in terms of three dimensions. One is confidentiality of the data, then maintaining the integrity of the data, and authenticity of the data. These are the three fundamental principles on which the security of the current digital world is mainly associated with. Now, these principles of confidentiality, integrity, and authentication provides us an assurance that whatever the information that is either we are creating or we are using or we are transferring is trustworthy. And also, this particular data is only available to the restricted set of people who are the authorized users. Now, these principles, determine the various aspects of implementing the cryptography functions. Of course, I will be talking about this, but essentially, when you look at this, the security, we are talking about confidentiality, integrity, and authentication. Now, but why are when you look at the just a glimpse of the data that actually we are either creating, if you look at some of the statistics, of course this particular infographic is available online. You can google it by giving the word keyword called data never sleep. So this is the latest infographic from this company. When we are looking at the some of the the online, say take an example Google. On a given a minute, there are about 6.3 million searches that are happening in the Google. People are looking at Google for various search purposes. Similarly, we all communicate with our WhatsApp. So given a minute, there are about 41.6 million messages that are being transmitted through WhatsApp. And we all know that WhatsApp is a kind of end-to-end encryption. Why it is being popular is because of the end-to-end protection or end-to-end encryption that it is providing, meaning the users of this WhatsApp are confidently using it because their data is protected, their communication is protected in the form of end-to-end encryption. Like this, if you look at various online popular platforms, whether it is an Instagram, whether it is a Facebook, whether it is a LinkedIn, given a minute, the kind of amount of data that is being generated, including the chat GPT. Now, if you look at, there are about 6,944 prompts that are being posed to the chat GPT, and I'm sure that this number may be little lower side when you actually come when the when actually if you look at the statistics of the chat GPT, I think I am assuming that may be much more. So these are the kind of a statistics, meaning the presence of users on the online, meaning the people being availability on their digital world is increasing. The communications that they are doing is increasing. The transactions that they are using, that they are making is also increasing, meaning lot more communications are happening, lot more data is being exchanged. Now the question obviously comes is whether my communications, whether my transactions, whether my data is all secure or not. When I say secure, the previous slide I talked about the three dimensions. One is the confidentiality, another one is the integrity, then I also talked about the authentication. So meaning when I say confidentiality, it is only the authorized users should be able to read that or should be able to access the particular data or the communication. Integrity means only the authorized people should be able to modify, should be able to perform and update kind of things over the data transactions. Similarly, authentication means you should actually authenticate who are the users. Now, when we look at our day-to-day activity, we all carry our ID cards, right? So RD cards is one of the best example. We all give our biometric details to enter into a campus. So providing an authentication, we give our username password to enter into an email system. So this is kind of a thing which provides the authentication, meaning whether the person whether the person or an entity which is object which is making an access request is an authenticated user or not. Once this authentication is done, you have another layer of security called authorization, right? So to what extent this particular authenticated user can access the resources, that is the level of authorization. So these are the various security fundamental look at the data security. Fundamentally, what is data security? It is a subset of information security and focusing on protecting sensitive data and also the personal data from unauthorized access, also alteration and destruction. So preventing unauthorized access of sensitive data. When I say sensitive data, this could be individuals data or this could be organization data. This could be any data which is treated as a sensitive data. Of course, the question also comes, sir, how do I detect or how do I classify a particular data as a sensitive data or not? So that is a different ball game. So I'm talking about once you have a data that is classified as a sensitive data, so how do we protect it? Similarly, personal data. This is in fact now more and more awareness is being, and also people want their data to be whatever is their personal data that is to be protected from unauthorized users and also providing integrity to this particular personal data. So essentially, when you want to protect the data effectively, either in the organizations or the personal data of the end users, you has to have a detailed data security strategy. Now, when I say data security strategy or a data security, a framework for an organization or for a personal data, there should be a framework providing entire data security strategy. Means number one should be having data encryption standards to prevent unauthorized reading of stored or transmitted data, right? So one should have encryption of the data. Then one should have data masking. So I will be talking about the data encryption. So data masking, meaning to hide the real data values in the non-production environments. So meaning what to disclose, what not to disclose. Similarly, whenever there is a need to disclose, hide the real data values so that you are going to protect sensitive data. Then next aspect is data erasure. So once you have used the data and no more this particular data is required or no more this data would be used, obviously the data that is no more required should be either destroyed or should be erased. Even for that, there should be a strategy. So how do we securely delete data so that that would no longer be in the hands of cyber criminals, right? So there should be a strategy for secure data erasure, meaning like we all have some policies about how to discard our waste. So this is also similar to that. Similarly, next one in the pipeline is about the access controls. So how to provide access, what to provide to access, or to whom access to be provided. These are all related to providing access controls and as well as monitoring systems. There should be effective monitoring systems to see whether there are any kind of threats, whether there are any kind of the cyber untoward incidents, even that also need to be reported. So first of all, one has to detect such the threats and also respond to the threats. So one should have a sophisticated monitoring systems in place in the organizations to detect as well as protect from the cyber untoward incidents. So in that regard, if you look at the data security pipeline, you have lot of things to be done: data encryption, data masking, data erasure, access controls, then compliance to the legal regulations of protecting the data, then finally have the trust building. So once if you have all these things in place, from encryption to masking to erasure to the controls to the compliance, that gives us the complete trust over the organizational the data framework. So one, why we should have data security, what is the importance of it? Obviously safeguarding the sensitive information, mitigating the risks and protecting the data from the vulnerabilities, then maintaining the customers trust and loyalty and compliance with the regulation. This particular infographic or an image is talking about protecting the data, or importance of the data security from an organization point of view. Of course, the same also holds for the personal data. So take an example, I am using a particular online portal. So I wanted to know whether my personal data is secured or not. So it is whether it is my sensitive data is being protected or not, whether any cyber criminals will capture my data and misuse my data. So these are all the concerns that I will have as an individual, and hence you have importance of protecting the data. So there are various benefits of having the data security, preventing the data tampering, avoiding the additional cost, ensuring the legal compliances. So these are all various benefits of data security. I'm not going to explain because these are all self-explanatory, and of course I have given the even in the previous, I think my suggestion is go to this particular website of Palo Alto Network, talking about what is data security. All these images are available, and also the illustration. So these are all self-explanatory. And then when I say that you have this data security requirement, and then benefits of data security, but the question comes, whether data security is easy to achieve or have some kind of a challenges that are there. So obviously securing data is not so easy. There are several challenges, meaning the data that whatever we are want to protect, that may be the data which may be in the rest, but also the data may be in the transit, meaning data may be moving. Then also protection controls would be keep changing. They are in the dynamic environment. Similarly, when you look at the regulatory requirements, they are also overlapping regulatory requirements. And on top of all that, most one of the important challenge is that the attackers, the attack your attack landscape is continuously evolving. So that is another important dimension. Then fundamentally, there would be certainly in any system there will be organizational gaps, human talent gaps. So these are all the various challenges that are there in achieving the data security. Now, having said all this, what are the various data security approaches? Now, I know that I have my personal data as an individual. As an organization also knows that it is handling couple of thousands of customers data. Above all that, organization data itself need to be protected. So what are the various approaches? Obviously there are n varieties of approaches. Each approach is taking care of couple of subdomains or dimensions. So take an example, you have foundational protections. This is one dimension of data security. Then complying to the governance or the legal regulatory bodies, there is another dimension. Then responding to the threats and then achieving the resiliency, that is one dimension. Then finally environmental specific safeguards, this is another dimension. Now for each of this dimension, various data security approaches are there. So when you look at the foundational protections, fundamentally you have encryption is one of the approach to provide security to the data. Then you have access controlling. You can define certain roles to the individuals who are accessing the data, and then provide the controls over the access based on the roles. So we call it as a role-based access control. So this is another approach to provide data security at the foundational level. As I said about the authentication, data masking, data erasure, all these things provide the data security as a foundational protections. Now, compliance to the legal regulatory bodies. One of the legal regulation is European Union has a policy of GDPR. The people call it as a GDPR. So how do we comply to that particular legal regulations, and how do we classify the data? How do we prevent the data loss? All this comes under your visibility and then governance, right? So like this, we have various data security approaches. In this talk, I would be focusing on the foundational protections, meaning your encryption. Fundamentally, I will talk about what are the things that are happening in encryption aspect of data security, right? So of course, this I have already mentioned, various types of data security, right? As I said, fundamentally, you are having a data in three different states. One is data is there at rest, and data is in transit, and then data is in use, right? So how do I protect? Fundamentally, when the data is in rest and when the data is in transit, moving, when it is being communicated between either the devices, either across the networks, how do we protect the data? Then similarly, when the data is being used, when the data is being analyzed, when the data is being used to take the inferences, now how do we protect the data, right? So these are the three different states of data. Then when you look at protecting the data at rest, fundamentally you need to understand where is the point of data at rest. Now with the data could be at the file servers at the network shares. The data could be in the you are stored as the management document systems. Then data could be there in the external storage devices. Data could be there in the traditional databases. Data could be there in the users endpoints like your laptops, PCs, mobile devices, or even the data could be residing at a particular cloud storage environment. So these are the places where the data is there, lying there. And of course, when I say lying there, I can say that data is stored, right? So when the data is in stored state, how do I protect the data? Obviously, you can have a couple of approaches in terms of full disk encryption or device folder level encryption, database encryption, then information rights management, data leak prevention, managing the mobile devices, then implementing the cloud access security brokers. So these are the various approaches that can be deployed to protect the data while it is at rest. Now you can also see the various mappings between each of the approaches and the data that is being there at different locations. Fundamentally, when you look at all these different approaches, you can see one common underlying principle which is called encryption, right? So ideally, when the data is at rest, the fundamental mechanism that is used to protect the data is the encryption. Next, the second state of data is in transit. Now the question comes, how do I protect the data when it is in transit, right? So when I say when the data is in transit, what is the meaning of that? The data is being transmitted. Say, take an example, it is transmitted through your email communications, right? That it could be data could be transmitted through the client and server applications. It could be applications such as, say, take an example, your banking transactions, online transactions, or maybe the communications may be happening between the two devices, right? When I say devices, it could be one classical example is our end-to-end applications such as WhatsApp, right? Similarly, you may be having the data being transmitted across local area networks or wide area networks, even between the nodes to the cloud, right? So, and fundamentally also possible that there is a collaboration platform such as Slack where the data may be being shared, right? The question obviously comes is how do we are going to protect when the data is being transmitted or when the data is in transit or data is in movement. So fundamentally you can see there is an email encryption, then managed file transfers, again information rights management, preventing the data leaks. These are all the fundamental approaches that are deployed to protect the data when the data is in transit. Next, you have the techniques to protect the data when it is being used, right? So when I say data being used, obviously when you have a data, when the data is in stored form, when the data is being transmitted, we are having the protection mechanisms. On top of that, data is being used. When you have stored data, when you communicate that data, obviously, we need to perform some kind of an analytics, some kind of an inference calculations, right, to fundamentally perform some kind of an inferences. Now, the question comes, obviously, how do we protect the data when the data is being used or analyzed, right? There are, again, various mechanisms. Some of the mechanisms that it was shown here are about the access control based, identity based access management. What I will be talking or much more than this when the data is being used. Also, when you look at the literature, you might have seen some of the terms like data security, data privacy, data protection, right? Each are having their own goals. I will only talk about what is the primary goal of data security, what is the privacy and data protection. If you look at the primary goal of data security, it is to prevent the breaches, and it is to prevent the data thefts, and it is to prevent the cyber attacks. Now, when you look at the data privacy, it is also to ensure the data, how it is being used, whether it is being used according to the consent that is given by the users. So take an example, as an end user, when I am the owner of my data, I should give the consent for what purpose this data is being used. So when somebody comes and collects my personal data and then saying that, I am using this data only for this purpose, now how do you ensure that the collected data is used only for the purpose of for which it was collected? So that's about the data privacy, right? So the data protection is about securing the data and as well as ensuring the compliances with the regulations. Meaning what? Data protection is a broader umbrella, and then your data security and data privacy put together are part of your data protection, right? So fundamentally, one has to understand that preventing the breaches, ensuring your confidentiality, integrity, authentication are part of your data security. What is data privacy? How you are actually handling the data. Yes, there is an user who is having authentication to access a particular data item, but how do you ensure that the user who has the authentication or authorization to access the data is properly using the data or not, is about the data security, data privacy, right? So this is about all the fundamentals. Now, coming back to the core concept of ensuring the data security, I have mentioned about on the foundational approaches, you have cryptography being used as the fundamental mechanism. Now, if you look at the cryptography, all of us know that, we actually use communicating parties like Alice and Bob in the crypto world, where Alice is the sender and Bob is the receiver, and the communication channel that they are using in between is an untrustworthy network, which you can say that which is a kind of an internet. And when I say that it is an untrustworthy network, obviously there is a eavesdropper always possible, and imagine that the eavesdropper is the Eve. So you know that your communication channel is an untrustworthy, meaning there are spies who are spying on our data. There are chances that not only spying, they will also be able to modify our data. So now the question comes all about how do we protect from spying and then modifying it. So the cryptography is the fundamental mechanism providing us the art of or science of secret writing, meaning the communication that goes between Alice and Bob goes in a secret encrypted or the scrambled manner, achieving three goals that what we have talked a few minutes back on: confidentiality, integrity, and authentication. Meaning when sender Alice is sending something to Bob, obviously there kind of has some kind of a mechanism that scrambles the data, and Eve listening to that communication will not be able to understand anything, but rather at the receiver side, when Bob receives this scrambled data, he will be able to assemble it back to a original plain message, so that Eve only will be able to understand where Eve cannot understand. This is the fundamental philosophy of secret writing, or we also call it as the encryption mechanisms. So there are many factors that influence the security and privacy of data. Obviously, I said about you need to protect when it is in stored, when it is in transit, and all that. So there are various mechanisms from encryption, including public key signatures, message authentication codes that are ensuring protection against the alteration of data, meaning integrity of data. Similarly, protection of the sensitive content against reading, meaning it is the confidentiality. So you have the mechanisms such as the public key encryption, or the symmetric key encryption. We will talk about what is public key and what is symmetric key encryption in a few seconds. So fundamentally, these goals, especially protecting against the denial of service, stopping the traffic analysis, these are the various applications of the cryptography. And cryptography is not the current the order of when I say it's the latest, rather it has a long history, right? It is there from very olden period, and also it has evolved. Now currently what we are using is called modern cryptography. So those who are really interested to look at the ages of cryptography, I would actually suggest you to Google the history of cryptography, and you will come to know there are various classical techniques used by the ancient times, and then the modern times in the sense of the period that was there during the World War II, and subsequently the modern cryptography is all about the cryptography that is being implemented in the digital world, meaning the post World War II, or the era of internet based communication. I talked about the two types of techniques called symmetric key crypto system and then public key or asymmetric key crypto system. They fundamentally differ in the sense, the sender actually, when sending the data, will perform the encryption with the help of a particular key that is given as an input to the encryption algorithm. So an encryption algorithm ideally will be applied over a plain text message M, and I'm calling that as the encryption algorithm E. And then for performing the encryption algorithm, you need the plain text, and also key should be given as an input to get the ciphertext C. And at the receiver, you are going to run the decryption algorithm over the ciphertext and apply the same key to get back the plain text M. So since you are using the same key for encryption purpose and same key for decryption purpose, meaning the same key is used by the sender and the same key is used by the receiver, you call that system as the symmetric crypto system, right? So when I say the symmetric crypto system, as I said, you are using the same both ends. A fundamental challenge of this type of crypto system is, how do I distribute the key between these two users? Meaning, how this same key can be established between the sender and receiver. That is the fundamental challenge of the symmetric crypto system. Meaning, the sender is there in a particular location and the receiver is there in a different location. When the common key should be used between the both users, obviously how this key has to be distributed, meaning this key distribution should be secure. If they share it in an insecure manner, if key is lost, the attackers will be able to decrypt it very easily. So we are focusing on secure key distribution in the case of symmetric crypto system. Now, since this is a challenge, what researchers have done is, okay, the question is coming because of, or the challenge is coming because of the key distribution. What if suppose I have a one key called encryption key at the sender side, meaning sender will be using a key for encryption purpose and the receiver will use a different key for the decryption purpose. So meaning the KE and KD are not same, right? So there is, in such scenario, there is no need for key distribution because this key is different and this key is different. So the encryption goes with on the plain text with the help of encryption key, and you get the ciphertext, and at the receiver you perform the decryption over the ciphertext with the help of the KD to receive your plain text, right? No, you don't have the challenge of key distribution. In such scenario, actually, say take an example, this is happening at the Alice and this is happening at the Bob. Obviously, Alice should, and this asymmetric crypto system is also called as public key crypto system. Okay, this is also called as public key crypto system. The reason why it is called public key crypto system, in any asymmetric crypto system, any user should have a pair of keys. One is called public key, another one is called private key. Meaning, if you look at Alice has a key pair PUA, PRA. Similarly, Bob has a pair called PUB and PRB. So every node communication in the communication network, they should have a key pair in a way that one key would be used for encryption purpose. So now take an example, when the Alice is sending the message to the Bob, actually this KE that is used by the Alice is nothing but the receiver's public key, meaning the KE is the public key of Bob, right? So in the asymmetric crypto system, sender will use receiver's public key. That's what is the meaning of public key encryption. I repeat, in the asymmetric crypto system, is using the receiver's public key. Okay, so at the receiver will use the receiver's private key for decryption purpose, meaning the KD that is used is nothing but the private key of the receiver. So when Alice has used the public key of Bob and encrypted the message and sent it to Bob, Bob is using his private key to receive or to decrypt the message. So this is the beauty of this algorithm, meaning you use one key for encryption purpose and a different key for decryption purpose. So imagine if any eavesdropper Eve is there, wanted to decrypt this particular ciphertext, he cannot do. The reason is the Eve requires the private key of Bob, which is not possible for Eve because the key itself is private. Imagine if Bob loses the private key, then it's a different ballgame. We are assuming that the keys are kept secret, the keys are maintained in a secured manner. So this is the fundamental philosophy of a symmetric crypto system and an asymmetric crypto system, right? So what are the various popular algorithms? If you look at the symmetric crypto system, we have most popular algorithm currently being used is called advanced encryption standard. In the case of asymmetric key, we have various algorithms such as RSA, elliptic curve, Diffie-Hellman, and etc. Right? So again, I think in the interest of time, I will just skip the how public keys are created. My idea is to provide you the overview of various the encryption standards and all that. So now the point is, when you look at how actually this symmetric and asymmetric key are being used, if you look at, you can see here, this in the case of symmetric key encryption, Alice has a confidential data, used the key called K, and then encrypted the message, and that encrypted message is sent to the Bob. Bob has used the same key. You can notice the same key that is used, and then Bob has received the plain text back. So this is the symmetric key encryption, right? So there is one more interesting, aspect is that the asymmetric encryption I have mentioned. You can see here, Bob, imagine that sending a message. The message, this is the message, and encryption has happened with the help of Alice public key. Now in this case, Alice is the receiver. So receiver's public key is used by the sender and then encrypt the message, and the receiver is decrypting using the receiver's private key to receive the message back. So this is how the public key systems work, right? Now you can also see here, another interesting aspect is that Alice actually has used Bob's public key and Alice's private key and encrypted the message. Now, the beauty of this encryption, meaning, you are doing two types of encryption with the help of receiver's public key, and also encrypting with the help of sender's private key. I repeat, this is the receiver's public key and the sender's private key. When you encrypt and then send it, at the receiver side, you can notice receiver actually is using, if you know, the receiver is the Bob. Receiver is using the receiver's private key and also sender's public key. So meaning the scheme is used is, so if you look at this is the sender has used sender's private key of sender and public key of receiver. This is at the encryption side, and at the decryption side, what is happened is, key of sender, private key of receiver. So this combination is used. The beauty of this combination is that when you encrypt with the help of public key of receiver and decrypt it with the private key of receiver, what actually you achieve is confidentiality. When you do the encryption with the help of private key of sender and decryption with the help of public key of sender, then you are actually achieving authentication, right? So this scheme actually is achieving both confidentiality and authentication. That is the beauty of this type of schemes, these hybrid schemes, right? So this I will skip, in the sense that whatever I said in the previous slide is the authentication is leading to the signatures are providing the authentication, right? Now, one of the popular algorithm I said about the asymmetric cryptography is the RSA, which was introduced in late 1970s. This particular algorithm is on the important mathematical problem where we do not have a polynomial time algorithm that can solve the problem of finding the prime factors. So meaning, given a number, given a large number, how do we find the prime factors of that number? For that particular specific problem, there is no algorithm that can be executed in a polynomial time and provide the solution. That's the beauty of this algorithm. Based on that problem, the algorithm is built and then providing the security to the communications as a asymmetric key algorithm. You may come to know about why I talked about this algorithm later on, when we move on to some of the other slides, right? So, if you look at the beauty of this algorithm, you can see this particular number. Generally, when the RSA is used, used with a long numbers. So, if you look at this particular number, this is a 2048-bit number. If suppose somebody wants to read, you cannot say million, billion, trillion, and all that. This is such a number, such a large number, which if you convert into the binary format, gives you 2048 bits. So people use such a lengthy numbers, when while performing asymmetric key encryption, right? Next, you have another important cryptography primitives in cryptography is the hash functions, which people call them as the one-way functions, or the digest functions, where you provide the message to the hash function. So the hash of the message is called as digest. So meaning, this would be used for checking the integrity purpose. I repeat, it is used to check the integrity of the message, whether it is integrity of the message is there or not, integrity of the data is there or not. So that's the purpose of hash functions. They are different from the encryption mechanisms, meaning, you can, performing, taking a message and finding the digest is easy, whereas taking the digest and getting the message is fundamentally not possible or difficult. So that's the reason why these functions are called one-way functions. Okay. So what happen is, so for every message, what people do is, when the message is being sent, message along with the digest of the message is also sent. At the receiver side, what people do is, for the received message, they calculate the digest and see if the received digest and calculated digest, if both are same, meaning integrity of the message is there, otherwise they discard the message. This is where the hash functions are used. Similarly, there is another important dimension in the cryptography. We call it as the certificate, getting the digital certificates, where the digital certificates are nothing but, a few minutes back I talked about the sharing of public key, meaning when Alice is sending something to Bob, Alice is using Bob's public key. Now the question comes, how Alice knows what is the public key of Bob in an authenticated manner. So this is where your digital certificates comes into picture. So the certificates are nothing but, when I say a digital certificate, this is nothing but a certificate authority is certifying, the public key. So when you look at A, B, A will get a certificate from certificate authority, wherein which what is the content of the certificate. If you look at, this is public key of A. Okay. Similarly, what is the certificate of B? It contains public key of B. So certificate contains the public key of the certificate, that the holder of the certificate. Who issues that certificate? An authority issues. When the authority is issuing the certificate would be encrypted with the help of private key of authority. So now the certificate will be received by both parties. Later on, they will share the certificate. Now, B wants to verify the certificate of A. What B can do? B can decrypt that certificate with public key of certificate authority. Why? The certificate is encrypted with the help of private key of authority. So if you look at the beauty of this scenario, A will be holding the certificate, but the certificate can be verified by anybody, because verification requires the authority's public key. Certificate is issued with the help of authority's private key, meaning only authority can issue, but verification can be done by anybody. Right? That's the beauty of the digital certificates. There are various use cases of the digital certificate. All of us, in our systems, we hold, the digital certificates. This is an example of the digital certificate. Then digital signatures, which is used for the purpose of verifying whether, whether the meaning, authenticating the author of the message. Right? The digital certificates are different, digital signatures are the different. Right? So this comes into the picture. Remember, digital signatures are used especially in the scenario where there is no trust between sender and receiver. Okay, that is where the digital signatures are used, meaning when Alice and Bob are communicating with each other, but none of them actually trust each other, then your concept of digital signatures comes into picture, and for that purpose the underlying mechanism that is used is the hash functions, right? So you can also see here one of the fundamental signature mechanism. Alice is sending a message, but actually she is signing the message with the help of her private key, right? And then once that signature is done, the actual encryption happens to perform to achieve the confidentiality with the help of receiver's public key. And at the receiver side, the receiver will decrypt it with the help of private key of a receiver. But now the question comes, who actually sent this message? That can be verified because you are using receiver's public key, right? If suppose this part is not there, then what happens? Anybody can encrypt a message with the help of receiver's public key, but receiver will be able to decrypt, not be able to tell who actually sent this message. Now, if you, because of this particular signature mechanism, Bob is able to verify who is the sender of the message. So one has to remember, especially the students, the difference between the certificate and signature. Certificate is issued for the purpose of to know what is the public key of the other node. The signature is issued or signature is inserted so that from where this message is originated and who is the owner of the message, kind of a thing, right? So there are various mechanisms. These are all about securing the data when the data is in, when the data is in rest. Now, how do we protect, in terms of encryption? Now, how do we protect when the data is in transit? So when for that purpose, there are various scenarios. When the data is being moved across the internet, you have HTTPS. All of us know we day to day we use it because all our browsers, when you are accessing any website, you see HTTPS, where in which our hypertext transfer protocol, that whatever it is sending our hypertext data. When I say hypertext data, this includes your image data, text data, audio data, video data, whatever it is, that is encrypted, and hence you are getting this HTTPS, right? So this is where your data is being with the help of your HTTPS. Similarly, you have virtual private networks that are providing security to the communications, right? There are several threats that are there for the data that is being in transit, including man-in-the-middle attack, packet sniffing, session hijacking, then people performing the replay attacks. So the core mechanism, if you look at for the data that is being transmitted, end-to-end encryption is the one which is being used to have confidentiality and integrity. Protocols for this particular purpose called HTTPS, which we just few seconds back I said. You have also IPSec, secure socket shell, VPN, and etc. Right? These are all the things providing data security in the transit. Next, I will also talk about data security in computation. For computation purpose, what I have done is I have taken the machine learning computation or performing the computation for the purpose of machine learning as a use case I have taken. So if you look at the machine learning, we have various aspects. You take the data and then you build a model and then deploy it and then derive the inference of it during the testing phase, and finally you deploy it. So you can see a training phase and a testing phase, and fundamental to all this is the data, right? So this is the pipeline of machine learning, any machine learning model, and a very, very broader sense, right? Now, what are the various, the security related threats inside the machine learning? You have adversarial attacks, people talking about manipulation of the data that is fed to the machine learning model to build the machine learning model. So manipulation of the input data. Obviously, when a machine learning task like a classification that you wanted to perform, and obviously it is based on the input data you provide, but in case if there is any manipulation to the data, obviously machine learning model would be providing a false output or a false this one. Similarly, you have a data poisoning attack, injecting the malicious data intentionally to the training data sets. Similarly, you have a model extraction where the hackers would be performing the reverse engineering aspect of a model, right? Then fundamentally the privacy leaks. When the data is used for the training purpose, the sensitive data, if it is being inferred from the model's output, that's a privacy leak. So these are the various threats in the machine learning, right? So this particular table gives you an idea about when the data poisoning happens, when the adversarial attack happens, and how it they happen, then what is the impact of it, then what are the various mitigation strategies. But the point I would like to drive here is that what are the techniques for that? Now, one of the fundamental technique we have in terms of, again, coming back to the encryption, is called homomorphic encryption, where the concept of homomorphic encryption is enabling us to perform secured computations on the encrypted data. And fundamentally, when I say performing computations on the encrypted data, this is the key topic. What is that? You should not decrypt the data. Meaning, you have an encrypted data, meaning in the form of a scrambled data, do the computations on the scrambled data. The moment you decrypt it, you should be able to get the actual output what you get. Meaning, when some cloud server is performing the computations on my encrypted data, they will only do the computations, but they will not be touching my actual data. So I will encrypt the data and then I will feed it to the model that is there in the cloud environment. Cloud will perform my machine learning task or whatever it is, and then give me the final output. Only encrypted point only, but then when I finally decrypt it, I get the actual output. There are fundamentally various types of the homomorphic encryption called partial homomorphic encryption, meaning it provides only limited set of arithmetic calculations, like in the form of either an addition or a multiplication. Similarly, you have a somewhat homomorphic encryption. If you take either addition or multiplication, you can do only fixed number of operations. Whereas a fully homomorphic encryption is the one which actually we aim for, is providing access or supporting unlimited operations, while keeping your data in the encrypted form. So this provides, security from privacy leaks, model theft, data poisoning attack. So I'm not going to discuss the how homomorphic encryption works, but rather, this gives you an idea, right? So this particular image actually shows you the entire pipeline of it. So you have an user has some sensitive data. What the sensitive data the user would do is first perform the encoding, then apply the homomorphic encryption, and feed this encrypted data as an input to your cloud environment. This could be a cloud environment or an environment where the computations are happening in an untrusted environment. It could be happening in a cloud, or it could be happening in a different location, but this is an untrusted environment. Fundamentally, this is an untrusted environment. So now you are giving an encrypted data. Now this untrusted environment is performing the computations. This could be training a machine learning model on that encrypted data, then send the result back to the user. What the user will receive is the encrypted output, then perform the decryption, then decode the result, and then final output is given. So now in this case, if you look at server or the untrusted environment, do not have any access to this sensitive data, right? So only the user knows it. However, user's job is done, right? The user's job of performing a particular machine learning task is done by the server without touching the data. That's the beauty of the homomorphic encryption, right? These are the things that I have already covered. Right? You can see, there is a classic, example which is there online. There are certain codes also that is there. Those who are interested, so you can just see a simple use case, right? A client wanted to, do some operation, a kind of an image filtering or an image enhancement. So think that, you can't do it in your mobile or your device, and then you send it to a server environment by giving the encrypted image to the server. So server has performed, enhancing the image by applying certain filters and all that, but and send that result to the client environment. Now you see here the sensitive data is only at the client side, and the server actually do not have any access to the sensitive. Rather, this is all scrambled. But your operations of applying a filter or enhancement of the image is still happened at the server. This is one kind of an use case, just for your understanding purpose. Similarly, sensitive data that could be there. Ideally, we know that our healthcare environment, right? So client actually has an application where the symptoms of the patients are fed to the device, and then they are encrypted and sent to the server. Server is performing a machine learning task and understand the kind of a disease or provide certain suggestions and etc. Now you can see that are happening at the server on the encrypted data, and the model is giving you the output. Output is also in the encrypted form, whereas client will be able to decrypt it and get the results back in the form of a plain scenario. Now the privacy of the data is protected by applying the homomorphic encryption. And if you look at my suggestion is have a look at the various libraries that are programming libraries that are there either for Java or Python, etc. You have. So next you have another important data privacy related dimension called secure multi-party communication, multi-party computation, where multiple parties can collaboratively work on finding a solution to a function. When I say function, you need to feed the data, but actually feeding the data would be private. So I'm keeping my data private, but I'm working in collaboration with others. But we are working on a common function minimization task, but actually not sharing the data, right? So this is called secure multi-party computation. So you have various use cases for this. Next, another interesting the data security model we have is the federated learning, right? Where actually, if you look at the concept of federated learning is instead of sending the raw data to the central server model, and then models are trained over the local devices itself, and model updates are shared fundamentally. That's the beauty of the federated learning model, where in which it is advantage is that it is providing the data privacy, users data privacy, and hence you don't have the risk of data breaches, right? So how actually this goes is, you can see this mechanism, the diagram, you can see here, the models are trained local. So the data is there in the local devices, the data is there, model is also there, right? So then what happens, the trained model will be shared with the centralized server, right? The trained model would be shared with the centralized server. The centralized server will take this trained model, will create a global model, and then send it back to all the local nodes. So meaning, finally, when the global model is received at all the nodes will have collective intelligence without actually sharing the data. That's the beauty of the federated learning. So those who are interested, you can also explore the concept of federated learning. And of course, there are various strategies to do this or to implement this federated learning, federated machine learning, right? And it has difference with your traditional centralized modeling, and as in the sense, you are not sharing the data, and it's also different with the distributed machine learning, and it's also different from the decentralized machine learning. But fundamentally, you understand what is federated learning. One of the use case you can see here, hospital A has certain patients, and then they have their sensitive data, and the model is being built at the hospital A itself. Similarly, hospital B itself, hospital C, they share the built model, they share their built model to the centralized server, and fundamentally the centralized server will create a global model and send the global model to all the nodes. Now hospital A has a collective intelligence coming from hospital B as well as hospital C, but hospital B and hospital C have not shared the personal data of the patients to hospital A. So that's the beauty of federated learning. And there is another model of achieving privacy in the this one by applying controlled noise to the data. So it's called differential privacy. So these are all the various aspects that are ensuring your data security, privacy in the computation part. Blockchain is one of the fundamental mechanism that people are looking at because of its immutability property, hence providing tamper-proof records. Right. So this is also one of the interesting dimensions people can take. So as I said, there are several programming libraries, especially for the students who want to explore. So you guys can explore these various programming libraries. If you want, you can you can Google them and then get these various libraries, right, and then use them in the. So there are some of the best practices for using the data and then securing your machine learning models. Next, before I conclude, I will also touch upon the cryptography. I said a couple of cryptography algorithms and all that. Now people are talking about quantum era, where we are going to have a higher computational power than our traditional, even supercomputing power. We are not able to solve certain mathematical problems. One of the problem I said few minutes back about the prime factorization on which RSA security is lying. Now, with the quantum, there are certain algorithms. A few minutes back, I said there are no algorithms. When I said there are no algorithms, those algorithms we are talking about being executed on a computer, on a polynomial time on a classical computer. But there are algorithms that can be executed on a quantum computer, and they cannot be executed on a classical computer. So the fundamental algorithm called Peter Shor algorithm is the one which is actually solving the problem I said about finding the prime factors. So this algorithm, interestingly, was introduced in 1994, where even people do not have any kind of physical quantum computers. Now, with the realization of physical quantum computers, this into picture, and then people are realizing that this algorithm would pose severe threat to the fundamental problem on which your public key cryptography algorithms are lying, especially that is the prime factorization problem. Now, once that problem is solved, now your RSA, when I say RSA, it is public key cryptography algorithm. So your public key cryptography algorithms would be at risk, right? So, and because of that, people are looking at, and there is one more algorithm called Grover algorithm in quantum computing. This algorithm is trying to speed up unstructured search, meaning how this is connected with unstructured search means, there is a classical example there. Imagine you have a telephone directory, which ideally is a sorted form, but imagine that, you have a unsorted telephone directory, meaning what? The telephone numbers are given in a very random fashion. Now, how do you search with such telephone directory in a classical scenario? You need to have, n number of entities, entries, steps to get answer, an average of n by 2. Whereas in the case of Grover algorithm, it is much more simpler, which will be solved in a kind of a root n steps. So now, how this is connected with the security is that all our passwords, right? Somebody wants to perform a brute force attack with a Grover algorithm, it is possible, right? Now, considering these two algorithms into picture, people are talking about post-quantum cryptography algorithms, where people are trying to build quantum-resistant algorithms against the current public key algorithm solutions that are there. I'll just quickly go to the slide where I'll not touch this because in the interest of time. Of course, these lectures on this post-quantum cryptography in detail are there in my channel also. But the question is, what are the various algorithms? Right now we have various class of algorithms under post-quantum cryptography. We call them as lattice-based cryptography, code-based cryptography, multivariate cryptography, and hash-based signatures. These are the various variants of post-quantum cryptography algorithms. Especially those who are interested, please look at the NIST documents released on post-quantum cryptography. Now, these the variants have multiple algorithms. Again, as I said, have a look at the NIST. They are releasing these algorithms. One of the algorithm, so Crystal Skyber is an algorithm coming from lattice-based cryptography, and it is already coming into various products and protocols as a standard also. Right. Similarly, Crystal's dilithium is another algorithm coming from lattice-based variant of post-quantum cryptography. Again, that is also becoming a standard. Right. You can also see some of the algorithms that are still under the evaluation, meaning the PQC algorithms are still under the evaluation. Various teams are working on bringing the standardization to these algorithms, and down the line, people are expecting that these the classical algorithms need to be replaced. The protocols need to be having the post-quantum cryptography algorithms. That would be in the future. So especially those students who are interested, my suggestion is focus on them. So our team, just to come before I conclude, our team is working on various aspects of security, especially encrypted communication and ensuring the privacy to the communication. Then on machine learning front, the teams are working on explainable federated modeling with applications to various security problems and healthcare solutions. On quantum computing, we are also exploring the quantum machine learning and as well as the post-quantum cryptography. And we are thankful to the various funding bodies such as DST, MHRD, NBHM, also the seed grant coming from the VAT. Right. This just to give a quick overview of the kind of the recent work. This is the very latest work. Yesterday we got the the article that is published on encrypted traffic analysis using quantum machine learning algorithms. The thanks to our team of undergraduate students and other professors who are in our team. Similarly, it's also about homomorphic encryption schemes taking into the quantum fully homomorphic encryption schemes. Again, thanks to our undergraduate students and as well as the research collaborators. Of course, these are the papers that related to the security, but the team is working on different other problems, especially those students who are interested to do some of the innovative projects on these cutting edge areas. Please feel free to contact us. Similarly, those who are interested to enter into the cybersecurity domain, there are fantastic roles. Starting at the entry level, then moving forward at the mid level and advanced level. It's a fascinating field. People may have various transformations in other career pathways, whereas the cybersecurity is one of the area or a career path which fundamentally would be there always, right? Irrespective of other technological shifts that are happening in the various other fields. So with this, I would like to thank you all for the patient listening, as well as I thank the organizers for giving me the opportunity to talk to you. I hope that my lecture is useful. So as I said, those who are interested, they can contact us with this email. Thank you. I see a couple of doubts. Yeah. How is the data security different from general information security in practical scenarios? I'm not understanding what is general information security. So fundamentally, data security is an part of information security. That's what in the very beginning I have talked about. So data security, as a part of information security, and all these, the topics I have mentioned, these are all practical scenarios, right? Now you have a data that is stored, how to protect it, and then you have data that is being transmitted, how to protect it, and then you are performing certain computations, how to protect it. These are all the practical scenarios, especially to give you a feel. I mentioned about the 2-3 use cases of federated learning, homomorphic encryption. So these are all the various this one, right? So regarding usage of the tools, see, this all, the tools usage is based on your requirement, right? So what is your security goal? Every organization will have a security goal. That is one thing. Second thing, what is your asset that need to be protected? That is another dimension. So the asset that need to be protected will have a kind of security threat. So every asset will have a different security threats. So what is my threat landscape? What is my attack surface? Right? So based on that, your tool has to be decided. And of course, even across the tools, obviously there would be another interesting factor of the financials, meaning how much the tool would be costing. Yeah, the multiple factors. Any other questions? No, I did not say, somebody has asked, if asymmetric cryptography is more secure. I did not say in the entire lecture that asymmetric cryptography is more secure. In fact, asymmetric cryptography is now becoming vulnerable because of the SHAR algorithm, right? So, asymmetric cryptography has so far is used for one of the purpose that, if you remember a few minutes back, I talked about symmetric cryptography. The challenge is sharing of the or distributing the key, because the key is common between sender and receiver. How to securely send the key, that is the fundamental challenge with the symmetric key cryptography. That's why people went for asymmetric, because you don't have a key sharing. And another interesting thing is people have used this particular asymmetric key cryptography for the purpose of securely sharing the symmetric key. Okay, so but I didn't say that the asymmetric cryptography is more secure. So it's a generally students think first topic introduced is symmetric, second topic introduced is asymmetric, and because and hence asymmetric is secure. No, 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 it's not that way. In fact, as I said, asymmetric security is becoming vulnerable now. Leaving quantum, symmetric is secure in the sense of asymmetric, but symmetric is slower, asymmetric is fast. Asymmetric is slower, symmetric is faster. Okay. Yeah. Any other questions?
Sir, I actually would like to say a few words.
Sir, good morning, sir.
Hello, sir. Good morning. How are you?
Really nice, sir. It's a good session. Especially this is one of the real very important topic nowadays. So definitely our students will use this knowledge for their projects and as well as for their future higher study. Thank you very much, sir. I'll be in touch with you for collaboration
Sure, sure.
related to the
Thank you,
quantum
sir.
computing, sir.
Thank you.
So
Thank you, sir.
definitely, I'll be very thankful for coming or this particular session, sir. Thank you very much, sir.
Thank you, sir. It's my pleasure. Pleasure to talk to you and always interact with you. Thank you.
Thank you, sir.
On behalf of Dayananda College of Engineering, Department of CEC Data Science, I extend our sincere gratitude for the highly insightful and engaging session. The session was highly engaging and provided a clear overview of data security fundamentals. It explained cryptography concepts such as RSA, PKI, and digital certificates in a simple and practical manner. The discussion on quantum safe security and machine learning threats made it even more relevant for today's world. Overall, it was an insightful and inspiring session that deepened our understanding of modern data protection. We deeply appreciate you taking the time to join us online and share your expertise. Thank you once again, sir.
Thank you. Shall I leave?